Right, so were you guys able to download the Docker image? Except for Chris, because no Docker.
Yeah.
Nice.
I don't actually know what this does, by the way. Let's see.
Okay, so as I mentioned earlier, Zcash uses zkSNARKs to hide those three attributes of a transaction. So Zcash didn't always use zkSNARKs. They mentioned it in that video. It's based off of Bitcoin. So regular zkSNARKs transactions are actually the same as Bitcoin. So UTXO models, your transactions have inputs and they have outputs. And then you can obfuscate the transaction contents with zkSNARKs if you send shielded transactions to shielded addresses. So this idea of like a shielded transaction and a shielded address came in afterwards, after they did the ceremony thing and generated these like keys for you to create proofs. And it turns out that if you send a shielded transaction to a non-shielded address, then the entire thing breaks and is not completely private anymore. And it's also worth noting that privacy is a scary thing, especially when it comes to regulators. And if you need to do things like anti-money laundering, like you can't have private transactions because So a lot of exchanges actually, they'll let you trade Zcash, but they won't let you send it from a shielded address. Yes, so sending from a shielded address to an unshielded address will result in a de-shielded transaction. And this is what it looks like from a high level. In Zcash, they have this transparent value pool. So this value pool would be just like the normal Bitcoin mempool where all the pending transactions sit. And then there's this alternative Zcash, zero knowledge proof, shielded, protected input outputs. Any shielded transaction or any transaction sent from a shielded address to another shielded address would end up in this protected pool. And in both cases, this transaction fee will come out and it'll go to Zcash, which is an organization that has employees and needs to get paid. And yes. So when I made these slides, 13.4% of transactions were shielded, roughly 3% of all transaction volumes. Let's see what it is now. And it's around the same. Oh, it's not scrolling. Zoom out. Yeah, so why are there two? Sapling shielded. Oh, Sprout. Oh, so Sprout was the old one, and then Sapling was the new one, I think. So roughly 5% of Zcash transactions are shielded now, which is up from 3.4, or up from 3%, which is pretty exciting. Wait, no, this was 13.4. Oh, so I guess the percent of shielded transactions actually went down, which is fine. But yeah, so when it first started, or when Zcash first rolled out their protected transactions, it actually took almost 4 gigs of RAM to generate the proofs. Yeah, I started it. Yeah, originally it took around 4 gigs of RAM just to generate the proofs, and you would run it for a couple minutes on your computer. Your computer would get super hot and it would be just terrible. And then towards the end of last year, they had this upgrade called Sapling, and this was an optimization of their zkSNARKs verifying or proof generation algorithm. And that was pretty cool because it reduced the time it took to create proofs by 90% and also reduced the memory usage by 97%. So that means this is actually something, it's getting close to the point where you can like generate private transactions on your cell phone or on your embedded devices. Yeah, so these are more links, lots of links. This was that Vitalik's article. He talks about quadratic arithmetic programs. Give it a read if you're interested. It's worth it. Trust me. And then this one was also interesting by Eli Verbin. It was a talk at Web3 Summit last year. We're not going to watch this because it's half an hour long, but he talks about zero knowledge proofs and what they are used for and what they can be used for. That was this link here. Any questions about Zcash, Monero, zero knowledge proofs? Good.
I've got like a high level question. What's the major difference between Monero and Zcash? Because most of the time when people talk about Monero and Zcash, they look more or less the same from the person outside of the field.
Yeah. So the major difference is that Zcash by default is not private, and you have to do this. You have to enable your shielded address, and you have to send your transactions to another shielded address in order for it to be private. Monero by default is just private. There's another thing worth noting is, so this is Binance, and you'll notice here, so if I want to send Binance out, if I wanted to send Monero to my Binance account, I need both this payment ID as well as the deposit address. And that's because this is different from, like, I think you guys did an Ethereum transaction the other day with Ali. You just send it to someone's private key or someone's public address, and as long as you had your private key, you could like sign a transaction and send them tokens or coins. In Monero, when you create a transaction, it just ends up on the blockchain, and the receiver doesn't actually, no one can tie that transaction between the two parties. So the receiver actually has to actively scan the blockchain for transactions going to them. And they scan the transaction using this like, what was it called? Verifier key. They call it a payment ID here, but that's probably just so it doesn't confuse people. But yeah, that's another thing. So like Monero, you require two things in order to send someone funds. This was deposits, and then withdrawal is the same thing. So you withdraw to an address, and then you also need a payment ID that belongs to the address.
Because if it was only your address, then you'd have no way of knowing who sent you that money.
Yeah. Right. So let's give zkSNARKs a try. I think you guys, did I send the link to the getting started page? I did. Right, so you can barely read that. Right. So in this like getting started with Zocrates. So Zocrates is a toolbox command line tool that they packaged into a Docker image that you use to run, or it does three things, or it implements those three algorithms that we talked about: the generator, the verifier, and the prover. So the generator and all of those three are encapsulated within Zocrates. So Zocrates, you can use it to define your circuit. You can use it to generate your proving key, your verifier key. You can use it to generate the verifier, if you were to do the verification on chain, that means you actually have to like encode your verification algorithm in Solidity or EVM bytecode and then like push it to the blockchain. Zocrates actually does that for you. So after you define your circuit, you can generate a smart contract that specifically verifies that circuit. So yeah, in this example, we're going to provide proof that we know the square root of a we know the square root of a number. So Zocrates you write your circuit in this kind of language that looks kind of like Python but is not Python, and you would create it and call it root.code. So I have it right here. So this language has these words, so field is a generic variable basically. So like when you say field result, that means create a variable called result, and then there are if statements in in circuits, but you can't put them on multi-lines like you would in a normal language, and it works kind of like a ternary operator. So this would read like, if a times a equals b, then 1, else is 0, and then return the result. So if the return from the circuit is 1, then that means it was valid. If it's 0, then that means it was false.
So this is a circuit?
Yeah, this is a circuit.
Okay, and I'm still a little unclear on what the circuit is, but it's not a. This isn't a Turing-complete language then. There's no
not at all.
loops, no.
Yeah, so a circuit, you can think of it as like
like an electrical circuit, inputs and outputs.
Exactly.
But I still don't quite understand like what the point of it is.
Yeah.
Like, where you're supposed to model.
The reason it has to like be a circuit, so this would be like a multiplication, and you'll have your inputs and then your outputs, and then this would be like your 2 inputs and your outputs, and then C would be A times B. And then of course like this would get more complicated, but the reason that you can do this is because, or you need to do this is because it you can generate proofs that prove you have a solution to the circuit.
Yeah, so this doesn't actually have to be like representing any problem and
This
like any business logic problem. You're just generating this only so that so that you can say that you know how to solve it.
Exactly.
Yeah.
But then the problem that you want to prove that you know how to solve, that problem has to be defined in a circuit, so that you can so that the verifier knows like what problem they're verifying the proof on.
Okay.
And
That makes sense. Yeah.
so in this example, it would be you want to prove that you know the square root of a number, and this function takes in 2 inputs, A and B. A is private, which means A is the secret value that you put into the circuit, but you don't want A to be exposed in the proof that you generate. And then any other parameter or any other argument in this function would be public inputs. So when you run the prover to generate a proof, you would you would send the proof as well as any other public inputs to the verifier to verify that you know your secret. So this is a very simple circuit where you have your secret A, and then the circuit just tests if A squared equals B. So B is the number that is known to everybody, is the public input, and you want to prove to everybody else that you know the square root of B. And that's true if if your secret squared equals the public input. Does that make sense? So copy this code and create this root.code file that defines your circuit. And then now you need to run the Docker container, and you also, since the Docker container contains contains the command line tool, so you need to copy this code that you just made into the container that you're about to spawn. And how you do that is, I did it here. Yeah.
If you just go into the Docker container, you can just echo out into a file as well. You don't have to.
Yes, you could do that.
Just like one less command.
Yeah. I wonder if I still have So this there was a Docker run command here. Run this to open the container, and then oh, it's gone now.
Yeah, so just copy this source and just echo it out.
I had it here, so I'll just do this. Oh, it didn't work.
You need to redirect this input. What do you copy?
Yeah, like you just echo and then you type it to the
Oh,
file.
you put, yeah.
Just keep running that over here.
Yeah, so after you get the code, after you get the circuit into the container, you want to compile the circuit. And you do that by running the Zocrates command line tool, compile -I your file, and that'll spit out a bunch of numbers. So it turns out that this is what it ends up being. And then out of the compiler came this out.code file. So what is that? We have no idea what this is. But this supposedly is your circuit in a more machine-friendly way. Or it is supposed to be human readable actually. The machine version is like that. Right. So now we have our circuit, and we want to do our setup. So the setup, remember, it generates the proving key and the verifier key, and you do that by running Zocrates setup, and then you get all these big numbers. And these are basically points on the elliptic curve that you use that define your key. And then after, now we want to compute our witness. So this witness is the public, the witness is the public parameter that encapsulates the public inputs and your secret, and you use this to generate your proofs later on. So the example here was there's 337, which is my secret, and then the public input is 113569, which I think is the square of 337. So that's so now after running that, you have this like witness file. I think it's just a blob. No, it's not. It's a bunch of other numbers. Right, so now we have our witness, we have our proving key, generating verification key, and next we will generate a proof from our witness. So that's the proof. Yeah, there it is. You have more elliptic curve points, and yeah. Right, and like there's nowhere to put this proof, right? So how it works is if you're to create a decentralized application, is the verifier happens on chain. So Zocrates actually generates the verifier as a Solidity contract, and you can do that by running export verifier.
and then you'll get. Oh yeah, so you got this verifier.sol, which is a Solidity file, and if you open it, you'll see there are a whole bunch of things. So this basically contains all of the witness data, the verifying data. So this is the verifying key that was generated earlier. Now you don't have to copy and paste it, it's a function in the smart contract. And the smart contract also contains a library for executing for doing elliptic curve operations. So that's nice. There's also a nice disclaimer telling you not to use this in production because it hasn't been audited and it's just for learning purposes only. Yeah, so let's try and deploy this onto the blockchain. We have to get this verifier.sol file off of the container, which we would do it like this. I think you can click around. Yeah, so docker.cp is, in order to get this, this is the name of your Docker container. You can get that by running docker ps, and docker ps just tells you all your running Docker containers. And if you're not running any other Docker containers, this should be the only one you see. But otherwise, you can identify it by like the name of the image, which is docker keys/docker keys. And then you do docker cp. So this is kind of like SCP. If you ever, it doesn't work. Oh, I need my local. Yeah. So this is how you would like copy files off of your container into your local, onto the host. So now if I look at verifier.sol, there's like this nice syntax highlighting stuff, and there's a lot of math and numbers. Right. So how you would, the easiest way to deploy a smart contract would be to go to Remix, as I showed you guys yesterday. Alright, so I just copied and pasted the contract into Remix, and then I don't think MetaMask is enabled.
Christian's doing
Did you guys get MetaMask with Ali on Monday and Tuesday? Okay. You are. Did he show you guys the faucet and like testnet and all those things? Okay.
Like, just maybe comment on this line or something. He's doing anything but committing a message, right? So. Do you have a compiler?
Yeah, I'm trying to. Is it on the emit?
Yeah.
Okay.
Yeah.
Yeah, cause it's not
Yeah. Dude, it works. Yeah, we just commented out the emit and it worked.
Yeah.
I'm just.
Maybe I should. It's probably not readable. How do I zoom
What
in?
does the emit do? Is it just like a message bus?
So emit pushes there's a Bloom filter in the Ethereum nodes, and they basically store events. So emit means to like publish an event. Yeah, but events are not for smart contracts; they're for people. So basically, every block that comes in, you can see all the events that have occurred in the log, or in the block, and it's basically a way to find out if things are happening on smart contracts that you're interested in. Yeah, so if you try to do this, make sure that the compiler version matches the pragma at the top of the file. So here is 419. Make sure in Remix you're also using 419. And then there was this thing. Yeah, I think emit was like, it was introduced in 424, so you might be able to go with like a newer version and then it should work. Yeah, so now it's green. So if you go with, I'm using 425, and that would, because before 424, you don't use the emit keyword, you just call your events, but that's super confusing because now all your events look like functions. Yeah. So after you compile it, you can, is this on testnet? Oh, I don't have any ether.
Do it. Go for it. Deploy it. What's the worst that happens?
Dude, I lose all my gaps in the ether.
Yeah. So if you fold all the functions, the file that got spat out by Socrates actually contains two libraries. This is the prover. Yeah, so no, BN256G2 is an elliptic curve operations library, and then there's another pairings library which is also for doing your proofs, and then there's this last one is the verifier. So you should be able to just deploy the verifier like this, and yeah, after you select your account and you press deploy, MetaMask should pop up. And confirm.
So Socrates is it specifically for Ethereum then? Like for Solidity?
It has all the export stuff, makes it super easy to deploy whatever circuits, proofs, and verifiers get generated.
Mm-hmm.
You could just like implement the verifier and any other thing that you want, but they already do it in Solidity for you, so it makes it really nice. Yeah, so this is the transaction for deploying your smart contract, and notice, so this is like a nice front end that shows you all the fields in an Ethereum transaction. So you have the hash of your transaction, the block height and timestamp are pending right now because my transaction hasn't been approved, it hasn't been mined into the blockchain, and it should stay pending for a while. But, oh, where'd it go? Yeah, so after it's been mined, it has a block height, so that's what block this transaction's in, a timestamp. This is the timestamp of the block. So, yeah. From is the address that generated or signed the transaction, and then to. There is actually no to field if you look at raw Ethereum transactions that generate contracts, but it's here anyways on Etherscan. And then at the very bottom, this input data, this is the actual bytecode that your contract, that defines your contract. So one way to tell that it's a contract is that it starts with 6080604. So this is basically initializing the stack. And then the rest of the stuff is just the rest of your contract. And you actually pay per byte of data. So the bigger your contract, the more it costs to deploy it. And notice that here there's the gas used by the transaction, and also like the gas limit, which is like the amount of gas you attach to your transaction. blocks have a gas limit. On testnet, I think right now it's 5 million on Robston. You can check by looking at the actual blocks. So this is block number 5 million something. And you can see the gas. Oh, they raised the gas. Yeah, so the gas limit now is 8 million. It's actually not that hard to write a contract that exceeds the block limit, or the block gas limit. So if that happens, you have to refactor your code, break it up into more contracts, and deploy them separately. Does that make sense? Yeah. Yes. So this is my contract that got deployed. I think if you click on your contract in Etherscan, you'll see a bunch of things like what's the balance attached to the contract. So contracts can hold Ethereum, and that's because contracts can hold Ether, and that's because in Ethereum, smart contracts are the same as their accounts, or they are accounts, just like you are an account on Ethereum. You have a private key and you have a public key, or you have a public address and a private key associated with the public address. Contracts only have public addresses and don't have private keys. The other difference is that contracts have code associated with them, but besides that, they are exactly the same as external accounts, which are accounts with private keys. Yeah, so contracts can be on the receiving end of transactions. They can also be on the sending end of transactions, but they cannot, or they won't be on the sending side because they cannot sign off on transactions, but you can send a transaction to a smart contract that kicks off another. It wouldn't be a transaction anymore because it's within the same block, but it'll kick off a message that can go to another smart contract. So smart contracts can call other smart contracts that call other smart contracts, and they could also send Ether to each other. They can send Ether to other accounts as well. And yeah, so on the smart contract code, there is these other tabs. So there's code, which is not very useful. So this is the code attached. This is the code that defines how the smart contract behaves. If you are nice and open source, you can click this verify and publish button, in which case you'll get onto this page, which prompts you to publish the code to your smart contract, which we will do. So this is, so what happens here is when you paste your Solidity code, Etherscan has a built-in compiler, and they'll compile your code. And if it matches the deployed contract one-to-one, your contract will be verified, and everyone can see your Solidity source code. So we do that by going to Remix, copying everything, and just pasting it in. And then there'll be a couple other things, like on the contract name, it'll ask you for the contract name and what that is. So there'll be, usually there are times where Solidity files have multiple contracts in them. And when you deploy a contract, you're really only deploying one contract. Usually there are multiple contracts, so you can kind of like, instead of it'll be the same as when you do a import on another file, or like when you do includes on other files, you want to use functions from other files. A lot of the times they just kind of end up in the Solidity code. So when I deployed the contract, I deployed the verifier. So here for the contract name, I put in the verifier, and then make sure I use the same compiler, which was, I think it was 425, right? 425. Yeah, and then I think optimize is set to false. You can't see it, but yeah, optimization is disabled by default. So you have to make sure to also disable the optimization when you're doing the contract verification. Yeah, and then usually if your smart contract had a constructor and that constructor took arguments, then you need to put those constructor arguments in here as well, because that's part of the, otherwise the bytecode won't match up. What was I doing? Oh, I had no constructor, so I don't need to do that. Oh no, this is the hardest thing ever. I swear these are either getting harder or like I'm becoming more of a robot.
It's really interesting that you mentioned that smart contracts don't have private keys associated with them. So
Yeah.
like to take money out of the smart contract, you would have some kind of functionality. So this like address can like call in like nobody else.
Exactly, yeah. So in Solidity there's a built-in function called send, there's another one called transfer, and that's how you would get Ether out of smart contracts. And if you don't have that, the Ether will be stuck in the smart contract forever. Yeah, so it compiled successfully. So it's nice and green. And here's the bytecode. And if you go back to the contract, you'll see there are more tabs now. So now the code has a nice green check mark, and then you can actually see the code or the Solidity that compiled into this contract.
I didn't get this contract verification page. Like it just transaction just went through. And
Oh, you have to click the, I think it's the to field where your actual smart contract is, or the hyperlinked like to.
Oh.
Yeah.
Oh, okay.
Yeah.
Okay, cool. There it is.
Yeah, so after you verify your smart contract, the compiler, or it wouldn't be the compiler, but like the Etherscan actually picks out all of the public functions and the public variables, and they put them into these nice, oh, there are no public variables, but there are public functions, I think. Yeah, they're public functions. So this is where you would go and like paste your proofs, because these are, so this is a function called verify tx, and then that takes in an argument a, an argument ap, and a b, and a bp. It actually has a bunch of other fields, and then the input. So yeah, and then this is one way to call smart contracts without actually going down into your node and like sending your node RPC commands. You could do it through Etherscan. So we generated that proof earlier. Let's try and put it into this smart contract to see if it was correct.
Why does it say that this verify and publish is new on Etherscan? Does it just mean that previously you had to verify and publish elsewhere, like without, like it was just new to Etherscan?
I'm just, actually that's been new forever.
Oh, okay.
I feel like, yeah.
Are there other ways to verify and publish?
As far as I know, Etherscan is the one that everyone's been using, and it's the only one that's available.
Okay, cool.
So,
thanks.
Are there any questions so far? Right. So earlier when we were copy and pasting those commands, there was one that was generate proof. So that generate proof created this proof.json file. And if we look at that, you can see that this, kind of readable, but there's this proof parameter, and then this has all the, I don't know what these would be called in JSON, but it has all the arguments that you need to put into that function that we saw on Etherscan. And let's try it. I think, yeah. So this is a 250. This is an array size 2 of 256-bit integers. So how you do arrays, I think they're comma separated, I don't remember. Let's just try to copy this. So that's A, put that here. Does it like it?
Integers was like a long.
It is quite long. It's I remember I was working on this project where I had to put because if you so ether, or there are no floating point, there are no fixed point numbers in the EVM. So what they do is they make it a 256-bit unsigned integer, and then what you do is you just kind of like count 18 decimal places. So the smallest increment of ether is called Wei, which is 1 times 10 to the 18. Or it's 1 times 10 to the negative 18 ether. So that's like the smallest unit of Ethereum. And I was trying to store that into a database, and for some reason I didn't realize that you can't put 256-bit integers into databases. And yeah, that kind of sucks. So I think I just ended up putting it as a string, which worked pretty well. So B it's actually a 2 by 2 array, so you have to break it up into 2. Here's one. And here's the other one. Yeah, so after putting on all those numbers, first I connected my MetaMask, and this used to be red, so if you press connect, it would prompt your MetaMask to connect. And after inputting all these strings, you could press write, which will prompt you to sign a MetaMask transaction, and then that is this guy here. So this is a transaction which gets sent to any node on the Ethereum network, and those nodes are supposed to propagate your transaction to all the other nodes, and then as long as one of them picks it up and forms a valid block, that's when your transaction gets mined and committed to the blockchain. So notice here that it's actually, oh, there it goes. Yeah, notice here that you actually see which function I'm calling, and this only happens in Etherscan if you verify your smart contract. If your smart contract's not verified, then it looks like this. It just looks like it's just bytecode. And we'll go into more details next week, like what this actually looks like, or why it looks like this, and like what each of these little chunks of data mean. But right now, this is basically your function call. So your function call serialized and encoded, and then pushed to the blockchain. Okay. Oh man, how do I get my result? Is there a result? Maybe it's just success if it goes through. So if I change it a bit, remember when we generated the input, we wanted to prove that we knew the square root of 113,569, and then the rest of these proving parameters were generated because we submitted our secret. So if we just change this slightly, and maybe if we submit another transaction, maybe it'll fail. So this should fail because it doesn't. The proof that we provided does not match the input that we're providing this time. So let's see what it is. So now we have to wait again. Yeah, very fun. So you can tell this is like a pretty extremely proof of concept, and like probably none of your users are gonna want to like copy and paste a bunch of random strings into this obscure site. So essentially what you do when you turn this into a end user product is, with the exception of like the generation of the proof, because the generation of the proof is pretty obscure right now. It's like you're running a Docker container, you have to define your problem. Well, your problem should be defined by whoever created the problem. And then all you're supposed to be doing is you have your secret on the client side, and then you generate a proof. And then those proofs should be submitted by your client. Oh, I went through. Oh man. Wait, was it that one? Or was it this one? Or was it this one? Oh, I think that was what the events were for. It was probably the events. Yeah, we were supposed to check the events for the outcome of a. Here we go. Yeah, okay, so this is, on this last tab, there's this events tab. So this was, remember in that generated contract at the very end, not readable. Yeah, oh, that's still not really readable. Okay. So if verify with your inputs and your proof equals 0, then emit verified. So emit the verified event and then return true. We're not actually capturing the inputs right now because we're using Etherscan and it's submitting our transaction on our behalf. Oops. But here the converse path is return false and not emit a event. So notice how when we go back to our smart contract and you look at our events, we submitted 2 transactions. The first transaction was using the correct inputs and whatever, and then the second transaction I messed up the input so that it should fail. And then we look on the events, there was only 1 event, and this is the verified event. So this was in block 53. Oops. And then if you go back to the transactions, that was this one. So that was the first transaction that we sent. Does everything make sense? Any questions? All right, so that was like a pretty simple example. It took quite a while to do, but like now you can create zkSNARKs, like pretty cool. Yeah. So let's talk about why, or are there any other uses for this? Like, for what other reasons would you want to use zero knowledge proofs? So I was actually playing with this idea last night. It turns out like pretty much any, I mean, the reason that you want to use a ZK or a zero knowledge proof is if you want to prove the solution to some NP hard or NP complete problem, right? So something that meets those criteria would be like a game of Sudoku, right? Like maybe you want to automatically grade, you want someone to provide a proof, you want someone to generate a proof to you that they have solved a Sudoku, or does everyone know what Sudoku is? Yeah. So that's the game with the numbers and all the each row had to match, each row had to have one of each digit from 0 to 9, 1 to 9. Yeah. And you can't have any duplicates on the columns or the rows. So it turns out that's like a pretty hard problem to solve algorithmically. So you actually have to do it, and there's no like fast way of solving Sudoku puzzles. So one way that you could actually do this is like you could create a circuit that solves or that verifies, because Sudoku is easy to verify. You just go through each row and go through each column and make sure there are no duplicate numbers, right? So you could really just like create a circuit that encapsulates the Sudoku problem, and then have your users generate proofs where the input is their solution to the Sudoku puzzle, which is just a 9 by 9 row 9 columns, so 9 by 9 array, or 2D array with 9 and 9, right?
So yeah, you were saying so you could probably just do that for any NP hard problem then, right?
Yeah, pretty much.
Dumb way you could use it, because like you know how like prime factorization is NP hard?
Yeah.
You could check if like they could factor a certain number or something like that, and then you could multiply it to see if that's the number.
Yeah, so yeah, exactly. So large primes are extremely hard to factorize.
Another idea would be taking like a game of Sudoku, and so like you as a user would be like able to prove to the website that you solved a game of Sudoku without revealing the solution.
Yeah.
So that like other people would not be like able to copy you forever, but you could like actually tell them yes, it's solved it.
Yeah. Yeah, and now you can like turn it into a game with like a cash prize, and like maybe the first place will get like $100 and second place gets 99, and like it goes down from there. But you don't want anyone to reveal their solution, or else like all the money would be gone.
You do that for like homework problems as well,
Yeah.
or if you want a first person to solve it, get something.
Yeah.
You need to be able to prove that you've solved it.
Yeah. I guess I should have formulated the first assignment as a zero knowledge problem.
So we had to solve it and then submit the proof that we solved it.
Yeah, and I wouldn't have to mark it.
But it's like actually really interesting because so in Sudoku, like I think there is one solution or many solutions to like a particular Sudoku game.
I think that's how is that how they set the difficulty? Because yeah, if there are multiple solutions, then it'll be easier to solve. And if there's only one or two solutions, then it gets harder to solve. Yeah, that actually kind of makes sense, because I was always wondering like how they even like get difficulty into Sudoku. Like you're just putting numbers everywhere. Interesting.
I thought they just provided you with the free numbers. They could just provide more. Like
Oh, yeah. I guess the more numbers they provide you, the harder. Wait, no, the easier it gets.
Yeah, the easier.
But then the fewer numbers they provide you, the more solutions there are.
Yeah, that is true also.
There's also, when you route through it, some of them only have a very specific starting route, where there's only one possibility that you can do off the start,
Mm-hmm.
and then you go from like single possibility to single possibility.
Mm.
Whereas some at the start, there's like a few different places that you immediately know the answer to.
I see. Yeah.
So it kind of limits you have to look for where the specific one
Mhm.
number that you can figure out is.
Mm.
It would be really interesting, like to find a way to kind of obfuscate the code on the Ethereum blockchain.
So this code is always public. So this will live forever as long as Etherscan is up and as long as there is an archive node somewhere that has this code stored. So there are actually 3 different types of Ethereum nodes. There are light clients, which is like MetaMask. There are full nodes, which participate in the verification process but don't propose blocks. So full nodes aren't miners, they don't mine blocks. And then there are miners who run a full node and also participate in the block creation process. So they crunch, they do the proof of work and they like assemble transactions. And then there are also archive nodes, and archive nodes it's like 1.2 terabytes right now to be an archive node. And that's basically like you have the entire state history, and you could actually like roll back the chain and look at the state. And what the state is every private variable, every public variable, every account balance, and so forth. And every transaction that goes onto Ethereum that defines some sort of state transition. And by that I mean like transaction to a contract might end up changing some variable in the contract. And yeah. So this doesn't really make much sense if you just look at it, but then if you click this and it switches to opcode, now you can look at the opcode and like so like if you really wanted to figure out what this contract did, you could like just look at this, right? So obfuscating code on Ethereum it's not really possible because it has to be verifiable by other people. Multiple nodes have to be able to run the transactions and come up with the same, or multiple nodes have to be able to process transactions and end up on the same state in order for there to be to be agreed upon by everybody.
Yeah, before, were you asking about that?
Yeah.
It's like, is it possible to have non-open source Ethereum contracts?
Yeah. Oh man, I guess that depends on like what you're, because to most people this is pretty closed source.
Yeah.
But to the people who care, it's like, because if there was significant amount of money behind this, then like people will sit down and figure out what this does. But otherwise, like no one will care that I know the square root of a number. Like it's
I think if other people want to have closed source or private solutions, they'd just use a different chain. They'd use a private chain.
Exactly. Yeah.
Something that specializes in it. I'm wondering for the for these proofs, they're not like they're not cheap to generate. If you wanted to dynamically create proofs for like a game that had a lot of traffic coming through, and you were just generating a proof for even if it was just like the only authenticated accounts, you're generating a proof, it's still going to cost you quite a bit. Even if they're verifying the proof client side after the fact, it's still a costly operation, even with the optimizations in the I'm just trying to wrap my head around like how costly would it be to be dynamically generating proofs for like something like Sudoku or whatever.
It's a good question. So probably Zcash is the good use case for that, because before their upgrade it took 30 minutes to create a shielded transaction to begin with, and then I'm not sure how long it takes now. But generating a shielded transaction involves generating proofs, so that now it takes a couple seconds. Before it used to take a couple minutes. So it's coming down, but it's still not insignificant. So it's not something that you would do over and over again. So if it was part of a game, it would be something that you would do at the end of an event, or like it would be a sort of like checkpoint event or a checkpoint mechanism. It wouldn't be like something that you do every time you open your inventory or something, just to verify your account
beginning
balance.
Of a level or something.
Yeah.
And you'd have to create the proof like with the person's like session ID or whatever, that they're something unique to them, something unique to the
Do you know of any distributed apps that use like a proof system, like cleverly though? On Ethereum?
I found that zk die thing pretty interesting. I don't know if it's like an actual. Is it an actual thing? Oh, yeah, so he just like pushed. Wait, when was this? Yeah, so this was December, at the end of December 2018. Took 2.16 million gas for this. How much did our confirmation take? 1 point something. Okay, so they took twice as much. Is it easier to fail to do an invalid proof? So this was our valid proof. That was the first one. 1.6 million, and then the invalid route. It actually took a bit more gas. It almost took 2 million gas to do an invalid proof. Yeah, so I mean, this was actually pretty. It wasn't much more. 2.16.
The reason why you want to do a proof verification on chain is so that some side effect of that can happen elsewhere afterwards.
Yeah, and if you wanted to do things like transfer your tokens to other people, that transfer has to be agreed upon by everybody, and you cannot spend tokens that you've already spent. Right, that's a very important thing, because like spending money that you don't have is a big problem. So that's one of the reasons why like things like that have to happen on chain. For less critical things, you could also take it off chain. So as like a you could use something like Plasma, like a layer 2 solution, like Plasma, Raiden, Lightning. All of those things are, so basically those are like blockchains that happen parallel to the main blockchain, and they do checkpoints onto the main blockchain, but they don't have the same set of miners, or they don't have the same, they don't have as intense of a consensus mechanism as the main chain. So things can happen a lot faster. Yeah.
Is Plasma actually a thing now? Or is it?
Yeah, so Plasma is more like an idea. It's a way of creating your side chains. If you wanted to play with it, there's this company called Loom. So if you go to loom.network, they're actually all of their examples are like, wait, is it loom.network? It's not loom.network, loom.io. They are more they're game oriented. So loomx.io. Yeah, so they have a bunch of SDKs, and basically they make setting up a Plasma chain extremely easy. And yeah, they have examples using like Unity, like JavaScript. So they're worth looking into if you're interested in like how blockchain gaming is right now.
Yeah, that's cool.
Like I look at Loom, I think that the primary reason why Loom exists is for performance reasons. Like our pipe chains used for anything else other than for performance reasons. I'm asking is because like we've got so many blockchains focusing on performance, and I mean like maybe later than sooner they will figure it out. To mean that all of these layer 2 solutions would be fully gone, fully non-relevant.
Yeah. personally, I don't think main blockchains can hit those performance benchmarks without sacrificing a bunch of security, and mainly because of like the cap theorem, you just like you can't. It's probably not possible. Like I don't think I understand it enough to have a strong stance, but it doesn't seem like it's going to go away. And really, like layer 2 things are powerful because the security requirements are usually lower, so that's why they can exist. But they have their own kind of, there's like another kind of worms in terms of like so now like side chains are secured by a lot by fewer people, is definitely less decentralized than things like Ethereum, Bitcoin. Yeah.
So it means that it's really like a domain-specific thing for gaming and for something like that. So like it's not a general purpose layer 2 solution. So like a year from now, like I won't be using a room to interact with the Ethereum chain. I will be using it only to do certain things quickly on the Ethereum chain.
Yeah, so what Loom's examples, for example, one of them is a delegate call, which is like, it's like Stack Overflow. So this is its own plasma chain. And then they have a bunch of other examples, which are all its own plasma chain. So every application would be its own side chain, pretty much. I haven't seen any general solution plasma chains.
You know how, have you set up a plasma chain? Or do you know how difficult it is?
Oh, it is as difficult as what we just did. So Loom actually created a bunch of tools that lets you like bootstrap chains really easily.
Yeah.
And they're all here.
Huh.
So if we look at it quickly, which one should we look at?
Oh, there's like a truffle integration.
Yeah.
Oh, that's neat.
Truffle deploy. So this is deploying the smart contract onto the main Ethereum chain, and that's because your side chain has to do checkpoints to the main chain. Otherwise, it's like not really a So what happens is instead of having every single transaction, instead of having every interaction with your DApp go onto the main chain, it goes onto the side chain, and then this side chain has these what were they called? I think they were called validators. But basically, if I wanted to start a side chain, I would start it up, and then I will be like an admin. I would have like admin privileges to the smart contract, and I'll be responsible for committing blocks on my side chain onto the main chain. And it's basically these commitments that make whatever happens in my side chain irrefutable and immutable. So if I had a token on my side chain and I wanted my users to be able to transact this token on the main chain with other people so that it actually has value, then those commitments would happen every time I make commitments onto the main chain.
This is kind of a separate question. Okay. So with the zero knowledge proofs, you prove you know something without displaying the original secret. Is it like that's kind of what websites try and do when they have your password and then they take like the salted hash of it, is to not store the actual thing so that you can't be hacked?
Yeah.
So do you see that being used for more authentication, like websites trying to implement zero knowledge proof so that they never actually know your password?
Yeah. I mean, if you were to do that, then like just use like ECDSA signatures, because then you don't have to go through the whole like proof generation process. But definitely for authentication, it's a big thing. I had another point.
Yeah, there's the WebAuthn or whatever is like a newer standard that's already implemented in a lot of browsers. That looks like it's going to be replacing a lot of the passwords. But I agree that the being able to use your private key through something like MetaMask is pretty sweet.
Is this like
It's actually implemented on all major browsers already. I was surprised to find that out. I haven't.
Wait, what is this? This was like 2 days ago. Like, maybe it was updated a couple days ago. But is this like new OAuth or like?
It's.
Oh,
I
demo.
don't believe it's OAuth. It's but I haven't looked into it yet.
This demo will let you create a user and register using WebAuthn and authenticate yourself. Wow, no password. Oh, me and my bro. Oh my god. Expected PK cred. I have no idea what that means.
I see one.
Yeah.
It's the nice principle, but
I mean, it didn't ask for a password. Oh, okay. Cool. No, definitely. I think passwordless is something we should be moving towards, because like people suck at creating passwords. People suck at remembering passwords, and like I don't feel like password managers are cutting it, even though like I use a password manager. Because your password manager has a password that
And it's
you have to
belongs
remember.
Someone you're entrusting, like a company with.
Oh, yeah. There are local alternatives. Like there are some that don't sync to the cloud. I think 1Password had this like local vault thing. Does anyone use 1Password?
I use 1Password.
Oh, they used to have a local sync only. So as long as you're on the same local area network, you can like sync your phone and your laptop.
Oh, cool.
But someone was telling me that if you got that set up, you can cancel your subscription and then not do anything. Because if you cancel your subscription, you never ping their servers. And oh, this is recorded. But
I
yeah.
use KeyPass.
It's
just
Yeah.
a local, and then you sync the database through a cloud service like Dropbox or
Mhm.
whatever. So then you've always got the database with you. Cool.
KeyPass.
There's KeyPass XC, which is the community open awareness on. Yeah,
Oh.
so that one's Windows only, and then there's the community version like XC, which is open source. And,
There's a KeyPass Touch on iOS,
yeah.
which is really convenient. Just like unlock with your fingerprint.
Yeah, the other problem with like encryption is if you're like super if you're really concerned with security, you're supposed to assume that encryption or the current standards for encryption will be broken eventually, and because of that you're not supposed to store encrypted things in the public domain. So that means don't store encrypted secrets on the blockchain because they might one day be decrypted. Yeah, I think that might be like a little far-fetched, but like it's another thing to be aware of.
They'll be decrypted and then they'll be sent to the future via quantum entanglement.
Yeah.
It's about time sensitivity. Like usually, if I wanted to keep a secret, it's probably not worth much in 20 years,
Exactly, there's that
which
too. Yeah.
is why you don't usually care.
Mhm.
But if you don't want someone to find out, even for the next 50 years,
Yeah.
then yeah, you need to go further than our current stuff.
Mhm.
Going back to the zero knowledge proofs, I'm wondering if another good like analogy is think like math textbooks in like high school or whatever, they have all the answers in the back, something like that where you can do the problem, you can check to see if you did the problem, but it doesn't give you all the answers. And that seems like a kind of useful case for me, but you said that it would be for like NP hard problems, but what about non-NP hard problems? Why wouldn't you be able to or want to use it for simpler problems?
You definitely could. Like our example today was not a
Oh
NP
yeah,
hard.
of course.
Yeah.
Yeah.
Yeah, it really comes down to like if yeah, I mean like definitely it's not just for NP hard, NP complete.
It's just suitable for
yeah.
I see, yeah.
I like that they give you the homework problems, they're just hashed. So you can't go the other way.
really like how they named this after Socrates, because Socrates was the last man to know everything, and this is a zero knowledge thing, which is like, wow.
Yeah, it's pretty cool. It looks like a fun library to play around with.
Yeah, the documentation's like super short. You could probably read this in like half an hour.
Oh, that's
And then-
awesome. 'Cause I'm really confused by all these files that I had to generate.
The final
Yeah.
project in this context.
But I'm assuming you probably couldn't understand the math in half an hour.
Oh, I mean, it's written in Rust, so like you could probably go through the code and figure it out. But like, yeah, really, like all the files and all the things that it generated, you don't need most of them because they just end up in that Solidity file. The only things you need is, first you have to define your circuit, and then you have to compile it, and then you compute a witness. And this compute witness and generate proof are the two things that the user needs to generate a proof, and that's pretty much it. Yeah, there was another tutorial on their docs where it was compute a pre-image, or it's a proof that you know the pre-image to some hash. So a pre-image is if you have h of x equals y, then the pre-image is x given y without knowing x. Or yeah, the pre-image would be the input to the hash function. So this is another example on their docs. Yeah, I think this circuit is even shorter. Yeah, it's just one line. They have a library for SHA-256, and
It's called BAT, basic attention. It almost seems like a 1984 nerd control thing. I mean, the internet already has them. They're paid exactly. Hey William, you should switch to the dev version of Brave.
there's a dev version?
Yeah, you can get paid with the ads now.
Oh. This isn't my primary computer. Oh, it's off. Okay.
You get paid for seeing ads?
Yeah, you can set how often, because they
the
block.
BAT token?
Yeah, they block like ads on regular web pages, but then X amount of times per hour they'll prompt you and be like, "Hey, you want to view an ad?" and then you get paid.
Yeah, I think my home computer has like $7. It's pretty great.
From the ads?
No, I don't. There's just $7 in my wallet.
Every month they give you tokens for
Oh, I
free
see.
to give to people.
Oh, I see.
Just to encourage. Yeah.
Oh, that feels bad then. I'm not giving them to anyone.
Yeah. But now you can do the ads, so you'll actually get paid.
Amazing. But now I have ads again. Oh.
I'll get paid for not viewing ads.
Just outsource the ad. Amazon Turk, somebody.
Another idea for project,
Blockchain project.
Proof that you watched the ad.
It's a smart contract for just viewing an ad. The gas costs more than he would have made.
In order to prove that they viewed the ad, they have to answer a question about it.
With regards to the ad, you never have to. It's a zero knowledge proof.
Yeah.
helicopter in the end as well, just to make things more interesting.
Yeah, there's certain there are certain ideas floating around about like how do you give the data back to the users. So right now there you have these huge conglomerates like Facebook, Amazon, Google that just like they're basically huge silos of user data, and a lot of people are really optimistic that blockchain and all these decentralized technologies will allow you to take this user data and attach it to the user and have corporations pay the user to offer their data back to the corporations. I haven't seen any like concrete examples about how this can actually be implemented, but a lot of people sound very optimistic about this. So that could be one thing to think about.
And I guess you could probably, I don't know, I'm just trying to shoehorn this into everything now, but you could probably even use the zero knowledge proofs for that. Because so they don't like, so they don't have all your information, right? So,
Yeah.
Yeah. Like what they want, like if they want to show an ad for some specific thing, they only know that you like that specific thing or not.
For sure, yeah. Like I went through my Google account the other day and I like unticked everything. So they're not supposed to be showing me personalized ads anymore. And I get some really weird ads now.
One time I was talking to my friends about, you know, those weird spinner propeller beanie things?
Yeah.
Yeah, so I was talking with him and then I looked at the price on Amazon just because, and it's for the next 6 months. All I got was ads for stupid propeller beanie things like everywhere. Like Facebook, YouTube, these stupid spinner propeller beanie things. Just like flood. I got spam emails.
He only needs one more, I swear he's gonna crack.